Okay, so let's start creating our calculator project. Now for this demonstration, we're going to be using IntelliJ IDEA, and we're going to be creating just a new Java project, regular Java project. Just give it a name, and here we go. Just going to enter full screen so we can see this more clearly. Okay, now one thing I like to do, this is purely a personal thing. I know some teams don't work this way, but I like to create separate source folders for both the main application code and the test code. I find keeping the application code separate from the test code really helps when you're trying to explore projects, bring new people into a team. It makes it really easy to see what tests you've got there and what behaviour you're testing in your projects. So let's go ahead and do that now. We'll have source main for our application code and source test for our test code. Okay, so let's create a test class for our calculator. So I have a regular Java class in our test folder, and this will be a calculator test. Okay, so we've got our class. Now we need to think about what behaviour we're going to be testing first of all. What feature are we building first? Well, if you think back to the calculator demo, the very first thing we saw when we opened the calculator was the accumulator. The accumulator had a default value of 0. So let's go ahead and write a test for that. Okay, so the first thing to point out is the test name. Well, this certainly a lot longer than you might choose your method names in your production code. In test code, this is a really useful thing to do, is to name your test methods almost like an English sentence, so they're really descriptive. So any test code you explore, any tests you see running or failing or whatever, it's really obvious what behaviour you're actually testing there. Okay, so let's create a new calculator for us to test. Okay, so what's the first issue here? Well, straight away you've got a compile error. We don't have a calculator class to test yet. This is our first example of TDD, with our test actually driving our application code. So we don't have a calculator yet, so let's go ahead and create it. Okay, so going back to our calculator test, we can see it's compiling now. So let's add our first assertion. Okay, so what are we asserting? We said we want to make sure that the calculator, when created, has an accumulator of 0. Okay, so the first thing in the assert equals is our expected value. Do we just want a 0, or what do we want here? Well, this is an example of TDD actually driving the design of our calculator already. So we need to think about the types that a calculator is going to work with. Is it going to be integers? Well, probably not. That's not too useful to us just to work with integers. So let's make this a big decimal. Okay. So we want to make sure the accumulator is 0, so we're probably going to have something like this on the calculator. Accumulator. We'll have a get accumulator accessor. Okay, so again our test is back to not compiling. So the first error is the fact that the assert equals function is not available to us. So we can fix this by adding a dependency to JUnit, which we can do like so. And now we can statically import the function assert equals. But our test still doesn't quite compile yet. our test is going to force us to create the getAccumulator method, which our IDE can do for us like so. Note that's all we're going to do at this stage. We're just going to fix the compile errors here. We're not going to actually implement this method yet. If you remember back to the test cycle, it's the red-green refactor. So the first thing we want to see is a failing test. Okay, so let's add a test annotation to our test method and get this test running. Okay, so we've now got a compiling test, a compiling program. So let's run our test and see it fail. Okay, great, just what we expected. Our test is now failing. So it's expecting a value of 0, but the return value is null. Now what you might be tempted to do at this stage is start thinking about how we're going to manage our accumulator, how we're going to store it, but that would be jumping ahead a little. With TDD we really do want the test to be driving any implementation that we write. So for now, we're just going to return the simplest thing possible to satisfy that test. And as we come to build more tests, we'll extend this functionality to actually have a correct implementation. Okay, so let's run a test again. Now we can see our test passing. Okay, that's not too useful right now. We've just got something that can return a value of 0 every time. Okay, so now we need to add another test, which is really going to start to build proper functionality in our calculator. So in order for that accumulator to be properly fleshed out, as well as being able to get the value of that accumulator initially, we want to be able to set it too. So let's go ahead and create a test for setting that accumulator. Okay, so as before, let's start by creating a calculator. So what do we want to do now? We want to set the value of the accumulator and then make sure that the getAccumulator returns that same value. So pretty simple. Doesn't really matter what value we use, obviously. Okay, so let's come on to set the value of the accumulator on our calculator. And now we want to use getAccumulator again to make sure that that value has indeed been set. Okay, so the first thing, as with our previous test, we've got a compile error we need to fix, as this method doesn't exist yet. Okay, so as with the previous test, with TDD you want to see the test file first before you go ahead and implement that functionality. And we can see we do indeed get a failure as expected. So we're looking for the value of 23, but at the moment getAccumulator will always give us 0. So now, with this new test, we're being forced to go back and actually implement getAccumulator so it does something useful now. So, okay, so for now, let's implement this as just a private field of the class. Okay, so we can change getAccumulator to return this field. And setAccumulator will set the value of this field. Okay, so let's run our test again. Okay, we've now got our first test failing. Again, we've broken our initial test because rather than it being 0 by default, it's null. So let's just fix that by changing the initialization here. Okay, running our test again. You can see we've now got both tests passing. Okay, so this is all well and good. We've been using TDD. We've gone through the red-green cycle to implement something, admittedly so far, fairly basic. But we've been doing it in a test-driven fashion, using our 2 tests to drive out those new methods and behaviour. So we've not implemented anything in our application code. We've not been testing. And not been testing first. So, as we described the TDD loop before, it was red, green, refactor. And refactor could be refactoring the application code, or it could be refactoring the test code. Looking at the test code we've got at the moment, there's not too much there, but I can already see we've got some duplication here. So we're creating the calculator the same way in both tests. What we could actually do is remove this from our test methods and have a common test setup which is going to do this for us. So I'm going to have a method here which is going to be run before every test and is going to create that calculator for us. Okay, and running that test again. Still passes, good. So we've made a minor refactor, admittedly, of our test code, but it certainly reduces the duplication we had in our tests and keeps the test methods simpler and cleaner. It's always good to strive for test methods which are readable. So you don't want too much code in there, you want them to clearly state what they're testing and what they're verifying. So we've refactored our test code. Now let's look at adding some more functionality to the calculator. It's not terribly useful at the moment, it doesn't do very much at all. And as we saw with the calculator demo earlier, the reverse Polish notation calculator is a stack-based calculator. So, very simple thing we want to do with it now. Let's look at adding the ability to push values onto that stack and to drop values from that stack too. So, always start with our test code rather than application code again. So what are we testing here? Testing entering and dropping values. Okay, so let's create a few values to put on our stack. Doesn't matter too much what the values are, obviously, as long as they're different. So we'll set the accumulator as we did before, this time to value 1. Now we want to be simulating that enter key on the calculator, so probably going to have an enter method. Okay, so let's repeat this with the second value. And finally, let's set the accumulator to value 3. Okay. So at this point, what state do we expect the calculator to be in? Well, we expect the calculator's current accumulator to be value 3. So let's just add a test for that. Okay, so to test the stack is working properly as well as putting those values onto the stack, let's try dropping those values and making sure that as we drop a value, the calculator's current accumulator will change accordingly. So calculator drop, and now we expect the current value to be value 2. Repeat that operation, we expect the current value to be value 1. Okay, so we've got a reasonably fleshed out test method now. Let's look at fixing those compile errors and making sure our test fails. So again, not implementing these methods at this stage. Okay, we're all compiling, let's run our tests. Okay, good, as we expected, we've got our 2 previous tests passing and a new test failure for our new test. Clicking on the test error here, we can see this assertion is failing because the accumulator isn't changing after our drop. Okay, so let's go back to our calculator code itself. Okay, so let's start to implement the enter and drop methods. To do so, we're going to actually need a stack. It's no good just storing a single value anymore. So let's look at changing our big decimal accumulator here to using a Java stack. This would be a stack of big decimal values. And the very first thing we're going to have to fix now is our existing methods, the getAccumulator and setAccumulator. So what is the accumulator? Well, accumulator is the value at the top of the stack, so that should be pretty easy to return from the stack. Java stack has a peak, which will give us exactly that. Going on to setAccumulator. Setting the accumulator is changing the current value at the top of the stack. So let's use the stack pop to remove the current value at the top, and now push the value on top of the stack. Okay, before we go any further with enter and drop, let's just take a look and see if our current tests pass. Okay, they don't pass, they fail. We've broken something here, so why is that? So looking at our first test, the test that tests the default value, we can see we're getting an empty stack exception. So our getAccumulator method here is doing a peak, but there's nothing in the stack. So rather than giving us a default of 0, it's throwing that empty stack exception. So that should be easy to fix. Let's just add a simple test here on the value size. Okay, that should do it. Let's run our test again and see if we fix that broken test. Yeah, okay, fixes that broken test, but we've still got another test failure here. We're getting the empty stack exception again, this time in the setAccumulator. So this time we're doing a pop when there aren't any items on the stack, which is causing that empty stack exception there. So again, let's just introduce a simple test on the stack size. Okay, so running those tests again, our initial two tests are passing again, and we're just left to implementing these new enter and drop methods. So for enter, we want to be pushing the current value of the accumulator onto the stack. So that's pretty simple. And drop, again, is a simple stack operation, stack pop. Okay, so let's run our tests again. Excellent, we can see we've got full test passing now. So again, we were using TDD to drive out both the methods that we needed in our calculator class, and then once we saw the tests were failing, we used that same test to validate our new implementation.